So, as always, first thing we do is centre drill it. Just to get a bit of my loop on here. Pilot on this centre drill is about 3.2, 3.3 mils, so we're alright. A little bit faster, I think. That's getting hot. So. What I'm going to do here is I need to drill this hole out to the depth of that shoulder. It's going to have a little countersink or chamfer on the front because the bits are chamfered on the shoulder there. And then I'm going to open the back of the hole out to allow whatever arbor I am to stick out the back and further up the bore of the spindle. So these are 8s, 3.2, so I'm going to put a 3.3 hole, you know, quite well back, probably the full distance of that back into the hole, just so that I can, if I want, push the spindles right back in. So I'm just going in with a 3.8 first to the depth I want, and I haven't actually measured that. The depth I'm looking for is going to be, yeah, well, I'm going to go deeper than that. I'll probably go about 12 mil. So let's have a look. There's me 0, 1, 2, 3, 4, 5, 6, 7. That's 8 mil deep now. Just taking it gently. And that's 9. Tough old stuff, this stainless. It's 10. I'll bring you back when we're done. So, up with the drill. So I'm just going in with the 4.8 now. The shaft actually measures 4.9, but drills quite often drill a little oversized. So we'll see how we get away with this one. If it's big enough, happy days. If not, I know it'll fit in the 4.9. And that's it, into depth. So the 4.8 hole, and it doesn't fit. So, whoop, next size up, 4.9. So we drilled it 4.9, and it was still tight. So we're going 5 mil now. It's just whispering out, well, you know, a couple of thou out of the hole. There we are, that's depth. So, famous last words, but I will say, I've no doubt that will fit in the hole now. You watch. It does. And, oh, I was going to say I'm not deep enough for that because of that spindle. Yeah, so what I'm going to do is drill a counterboard hole in the back now, another 10 mil deep to take this area, so that you can put spindles right back in further. And it's going to want a little chamfer on the front to mate with that little chamfer there. So, I'll drill the next hole, bring you back when we got there. So, let's have a look. I went for 3.4 in the back after, and the spindles will now go, yeah, all the way in, so that's happy. Right, chamfer on that front edge now. I think I'll just use a little centre drill for that, I think, just a break edge. So let's just I think that's about all I need. See where that sits. Well, maybe a touch more. That's better. Okay. So, I'm going to finish this undercut properly in the back, and I need to put an M8 by 1 thread all the way along there to accept the nut. I've just put a little undercut in there for the thread to run into. And I'm just going to put a little chamfer, well, a chamfer on this front edge, because that is finished. I don't want anything sharp on there. There we go. And I will put one on the back edge when I turn it round again. So, screw cutting an M8 by 1 thread on the end of here. Now, I'm not going to make this a video on screw cutting, because there are hundreds and hundreds and hundreds of videos out there on screw cutting. I've already ground up a 60-degree tool, suitable for what I'm looking for, very small radius, or high-speed steel, and I'm about to set it on centre and what have you. But I want to set my compound on 30 degrees. The graduations are for setting angles on this lathe are about as much use as a chocolate teapot, really. So, what I do with it, it hasn't let me down yet, is I do have this 60 degree, it has to be 60 because it's a triangular tip, and I set the tool against the edge of my cross slide, and I can set basically my compound just there on the 30 degree. Now, there are one school of thought that says 29.5, you know, but 30 degree, it's a nominal. This is not a precision thread for a precision purpose. So, set my compound, lock it off. It's just a useful little thing that you can use if you've got a 60 degree tool, such as a tip tool like this, and that will give you 60 degree, and that is hunky-dory. So, just thought I'd share that with you. I'm going to set my tool up on centre. I'm going to square my tool up to the job, and then I'll show you the way that I've found will work on this lathe. So the first thing I need to do is set my gear train up. Looking at the Warco chart, 1mm pitch, top gear 50, centre gear 52, bottom gear 80, and the lines down between them show it's a straight line gear train. So that's exactly what I got. 50th, 52, and, oh, hang on, yeah, 50, 52, 80. And a quick tip just to verify your pitch. If I rotate a chuck one turn, just take any backlash out, and I'll put the little badge there up the top. My half nuts are engaged, they were before I did that revolution. I'll set zeros there. If I rotate one turn, my DRO should read 1mm. So there's, ooh, I went a bit past it, hang on. Yeah. We'll go 2 turns, will be 2mm. 2.02, 3.07, 4.02. I'm not going, you know, 360 accurately. 5.07, 6.02, 7, 8, so on and so forth on the DRO. So you know I'm on 1mm pitch. So happy days, on with the guard, and let's see what we can do. So this is going to be unorthodox. I'll show you how I'm doing it. I have got a bit of cutting compound on there. In fact, it's dried out. We'll have a little bit more. Right. I'm engaged. I'm on about 3rd or 4th cut here. Hang on. Start again. Now this is unorthodox. I wind into 0. My cross slide is on 0. And I've already wound this in 0.2mm. So, I'm not disengaging the half nuts. And I'm hand winding it. And that's cutting the thread. That's run out into my undercut. Wind the cross slide back one. And bring it back. Cross slide back to 0. In 0.1 on my compound. And take another cut. rinse and repeat till we're looking somewhere near. I'll give you a close-up on the threads. And here we go. And I have so much control, I wouldn't do this if it was a long one, I'd do it under power. But that's running to my undercut, back out with a cross slide, back to beginning. It's only 10-11 turns. Cross slide back to 0, put another cut on, take another cut. Very close to this shoulder when I run out because I didn't want to have a huge undercut. So wind back, hence why winding it, just for this little quick thread. And I'm nearly there already now. 0, take another cut. This is looking very close. Yeah, very close indeed. Wind it out. Just give myself a bit of space. And I'll just try that little nut on there. Give myself enough room. There we are. Right, where's my little nut? So, it's time to put my hands up. I measured the nut 2 or 3 days ago, knowing that I was going to do this on the end of the shaft. I already had a plan. Stuck my thread gauges in there and said, oh yeah, 8mm diameter and it's 0.75 pitch. Oh yeah, that's M8 metric fine. And I just had M8 metric fine in my head. It's not M8 metric fine. It's M8 by 0.75 pitch. So of course I've gone straight to my book, oh yeah, M8 metric fine, that's a 1mm pitch, and put a 1mm pitch on there. So when I come to fit my nut, no chance. Not a problem. I'm not a fan of this nut anyway. I do have an M8 metric fine tab, which is M8 by 1, which will fit on here nicely. So what I'll do is make a new nut, which I know is running true, and the taper in the bottom of the nut is running true, and it should pull these collets in sort of a bit better quality, knowing that this is cheap Chinese, shall we say. So, not only am I making the shaft, which is pretty much done this end, I will be making a new nut as well. So I've got so far with the project. I've got the spindle holder, the carrier, the body of it, and I got the spindle up to a certain stage where I've done the front end, albeit with the wrong thread on it. Anyway, I will be making a nut at a little bit later stage. So let's finish off the little spindle. Area. So I know I want an area along here of like 10.01, 10.02 diameter, 22mm back at least. I'm going to go for about 24. So I'll just touch on that front face there, give myself a 0, come back 24mm, and I'll just set my carriage stop. Let's have a look. It's 24.7. Let's just adjust it. Try not to drop the spanner. There we are, 24.1. That's close enough for what I want. Right, so I'm going to turn all this area up to that point to 9.5 diameter. So I know I'm 10.5 diameter at the moment. Just touch off. I know I can come around 0.5 aside. So I'll go 0.2. And did you see that? Did you see that? And the reason for that is that my lead screw is still running at a 1mm pitch. So I need to set my gear in back. Easy mistake of the maker. Just connected the feed, was expecting my normal sort of feed rate, and I'm actually set at 1mm per revolution. What a wally! Right, shall we try that again? That's a 0.125 millimeters per revolution feed rate. About 5 hour rev. Yep, we all make mistakes. 1 minute of not thinking. I've changed the gear ratio back now. So, happy days. I'm looking for a diameter about 9.5. And my diameter was approximately 10.5. So, I'm going to take about 0.4 a side off in total. 0.1 at a time. And then we'll have a measure. I'm just coming up my fixed stop. That leaves me 10.5 over like 24 odd diameter. 0.1 at a time. I've got a bit of cutting compound in my brush, hence why there's smoke coming off. And we'll just whittle this down so that we got a 10mm clearance. 9.5 I'm going to head for. But it's not important. If it was 9mm it wouldn't matter, as long as it's less than 10. Because I want to be able to push the bearings all the way along this shaft and only start fitting when they get to the area where they need to fit. I'll bring you back when we're close. So finishing cut on this now. I'm running the same cut again just to take any deflection out. And we should be near as diameter around about 9.5mm. As you say, if it was 9.6, if it was 9.4, it doesn't really matter. It's just scratching away really. So I've done the 9.5. I've just taken a couple of scratches off this. And I'm measuring 10.02 nearest diameter there. And 10.01 there. So I think I'm going to need to take a little bit of a polish on here and come back to it. So I'm going to polish that last 100th. I don't want to risk turning that last 100th. It's about right at the back here for the back bearing, but here it's about 10.02. I think that might be a little tight, so I'm just going to gently polish it. Ooh. So I don't know if you pick this up or not on the mic. 10.01. Just under 10.01. 10.01. So yeah, I've gone for 100th oversize for the 10mm bearings. Hopefully that'll be alright. I can always come back and polish a bit. I spent a little time playing with this, and I'm just a hair, an absolute hair, over 5mm. So I'm going to go for that, and it does measure the same all the way along. So tiny chamfer on the end, chamfer on there, chamfer on the front edge, right up the front there, and that's the diameter's done on the shaft. Well, that's the holder done, other than it's flat. The shaft done, other than figuring out how I'm going to attach something on the end of here. I've got my bearings. I need to make a 2mm spacer that goes between these two, and I now need to make a nut. But having said that, the temperature in here is now, where are we? Put the light on it. 31 degrees. It's 3 o'clock in the afternoon on a Tuesday. It's just too hot. I'm going to call it a day and call this video an end. On to the next one.